Hi everybody, and welcome to exercise 6 on page 43 of the workbook. Let's take a minute to read this question together. So an online company is selling t-shirts for a sports team. At time t equals 0 months, the team wins the championship and the revenue earned by the company rapidly increases. Specifically, the total revenue earned by the company after t months is given by r of t equals 2e to the t plus $3,000, where t is between 0 and 5. Okay, so what they're giving us here is basically a revenue function. They're going to ask us some questions about that now. Okay, so starting with part A, how much total revenue has the company earned after t equals 1 month? And we'd like to include units. Okay, well, in this case, notice that we're given the revenue function directly. Okay, that's the meaning of this function r of t that they've given us. Okay, so to find the revenue at t equals 1 month, all we really need to do is to substitute t equals 1 into that function. We should get our revenue. All right, so let's do that. R of 1 is going to be 2e to the first plus 3. That's a job for your calculator. That turns out to be 8.44. Okay, and then the question is units. How are we measuring revenue in this problem? Okay, well, revenue is being measured in thousands of dollars if you look at the statement of the problem, so those would be the units that are coming out here. Okay, and so we have just answered the question asked in part A. At time 1 month, the company has earned $8.44 thousand. Okay, or if we wanted to, we could also write it maybe in more standard form. Okay, like that. That would be just another way to write our answer. Okay, and moving on to part B then, this is a little bit more interesting of a question. How fast is the total revenue increasing at t equals 1 month? Okay, so now we're not interested in the revenue, we're interested in how fast the revenue is increasing. How do we answer a question like that? Okay, well, the how fast part is telling us we're looking for a rate of change, so this is really asking us for the derivative of the revenue function at 1. Okay, so we'd like to find r prime of 1. So to do that, we need a formula for the derivative, so we might start by reminding ourselves what the formula for r of t is and taking its derivative. How would we do that? Okay, well, let's see. First term looks like 2e to the t. 2 is a constant, so we'll kind of factor it to the side. And how do you take the derivative of e to the t? You might remember that that was the nicest derivative formula in the whole world. When you take the derivative of e to the x, or in this case e to the t, you're just going to get the same thing back again, 2e to the t. Okay, and then you come to the second term, the plus 3. What happens when you take the derivative of a constant that's by itself like that? You just get 0. Okay, so our derivative, formula for the derivative is just 2e to the t. And so to find r prime of 1, we're just going to substitute 1 into that formula. Okay, so let's see. That's going to give us 2e to the first. Again, that's a job for your calculator. That's going to wind up being 5.44. Now the question are units. What is that number being measured in? Okay, well, remember, it's a rate of change. We can maybe help ourselves figure out the units by thinking about what a graph would look like of our function. They didn't give us one, but we can still think about it. Okay, so we had t and r of t, and t was being measured in what was it, months? And r of t was being measured in thousands of dollars. Okay, so this derivative is a slope, and so its units should have the same units that rise over run does, thousands of dollars per month. Let me try that again. $1,000 per month. Okay. So we have just found the rate of change of the revenue. Okay, and I think that's, yeah, we answered both parts of that. Finally, let's see what part C is asking us here. So at what time is the company's total revenue increasing by $50,000 per month? How do we answer a question like that? Okay, well, start by asking yourself, what is the significance of this number that they're giving us? $50,000 per month. Okay, that is a rate of change. So what that's giving us is a value of the derivative. Okay, and $50,000 per month, that's if we convert units, that means we're just looking for where r prime of t is equal to 50, okay, because we're thinking of the 50 as already being in thousands of dollars per month. Okay, so to answer this question, we basically want to take the derivative and set it equal to 50. All right, let's see if we can do that. So we have a formula for the derivative. We calculated that up here in part B, 2e to the t. So algebraically, we're just taking that 2e to the t, setting it equal to 50, and seeing if we can solve for t. So we might start by dividing both sides by 2. So that's going to be e to the t equals 50 over 2, which is 25. Now, how do you solve an equation like that for t when the t is in the exponent? This is a little bit of an algebra situation. Okay, to solve an equation where you've got a variable in the exponent, generally you can take the natural log of both sides. Okay, the reason that works nicely is that the natural log and the exponential function are inverses of each other. And so you take ln of e to the t, the ln and the e cancel, and you just get a t out of that. Okay, so ln of 25, that's a job for your calculator. That winds up being about 3.22. And what should the units on that number be that we just calculated? Okay, notice that that's a value of t time, and so that should be measured in months in our case. Okay, so after 3.22 months, that's how long it takes before our revenue is increasing by $50,000 per month.